Hello students, today our topic is work and energy. Firstly, we will understand the concept of work and then later on we will understand the concept of energy. To understand the concept of work, firstly we discuss our daily routine activities. From those daily routine activities we can understand the concept of work. Firstly I can give you simple example that I'm standing here. If I'm standing here and I'm delivering a lecture, is this a work? So first example is that I am delivering a lecture. Is this a work? And the second example is that suppose I'm holding this marker, okay, or I can say that if a 10 kg of weight I can put on my head, then is this a work? So simply I can understand, if I am holding a marker, is this work? Third example is that if I push this wall, the position of the wall doesn't change. Is this a work? If I push the wall, is this work? From those daily routine activity we will understand the concept of work. Okay student. Fourth, if I can say, if I am preparing for exam, means if I am preparing for my exam, or I can say that if I am studying, is this a, if I am studying, is this work? And then example is that if I'm standing here, I'm in a rest position. Suppose I'm not able to change my position, but if I move some distance, suppose this distance, then I will change my position. Is this a work? So I can write down there, if I am changing my position, or I can say that if I cover the some distance, if I am able to cover some distance, is this work? And the last example is that, suppose in my hand this is the marker. If I move this marker from this position to that position, is this a work? If I'm not changing the position of this marker, or if I'm changing the position of marker from this position to that position, is this a work? The last example is that if I am change the position of marker, is this work? So students, here I write down the 6 example. From this 6 example we can able to understand the concept of work. Firstly, what is a work? Work definition is that from the scientific definition, if we can able to understand the definition of work is that when you have to apply the force, then some displacement is occur, then the work is done. What I can say student, the scientific definition of work is that when you apply the force on some object, suppose you have an object, okay, suppose you have an object, if you apply the force on this object, then this object displaces its position. Suppose it displaces its position this distance, and he cover those distance, and then the object changes, means when you apply the force, the object will move some distance and the object will displace. Then we can say that work is done. Means if you want to do work, you have the main of the two important components, One of the important component is that is the force, and other component, important component, is that the distance. If both components are present, then we can say that the work is done. So now we can understand the examples of one by one, in which we apply the force and in which the object is displaced its position. When the object displays its position, when you apply the force, it means work has to be done. Okay. First example is that I am delivering a lecture. Is this a work? Student, I am delivering a lecture. Now my position, suppose I am in a rest position. Okay, I'm not able to change my position. I'm in a rest position. It means in this case the displacement is 0. When the displacement is 0, it means work is not to be done. Okay. And the second example is that if I am holding a marker, suppose I am in the rest position and I am holding a marker, or we can say that for 10 kg of weight I am holding, but I am standing here, then already in this case also displacement is 0. I am not changing my position. It means displacement is 0. In this case also work done is also 0, and in this case also work done is 0. Third example is that I push the wall. Suppose students, I will push the wall. I will apply the force. ठीक है? I am applying the force continuously. When I am applying the force continuously on this wall, but wall is not changing its position, it means force we applied but displacement is 0. When force applied but displacement is 0, in this case also work done is 0. Okay, and now the fourth example is that if I am preparing for my exam, I am studying in this work. Students, again, if I am preparing for my exam, suppose I'm here, okay, and I'm studying, means I'm not changing my position. In this case also the displacement is 0, and when the distance or displacement, distance is a scalar quantity or displacement is a vector quantity, means here we can only say that what distance the object cover when the force is applied. So in this case also work is 0. Now fifth example is that if I am changing my position, from this position to that position, it means when I apply the force to my body and then my body will move, it means force is there, displacement is also there, and then work done is also something done. Then W is equal to F dot S, means in this case work is done, because in this case displacement is not 0. Sixth example is that I am changing the position of marker. Okay, I am holding this marker and I am changing the position of marker from this position to that position. It means when I apply the force, the object will move some distance from this position to that position. It means displacement is occur. It means some work has been done. Okay, so some work has been done. So students, from all these activity, what we understand the concept of work. The concept of work is that when we apply the force, the object will move some distance, and when the object is moved, then the work has to be done. If the students want to write down the expression of work, then we can say that, okay, now we can write expression of work. We represent work from the word W, and the force, we represent this force from the F, and the distance, we represent the distance from word S. Now we write down the expression of work. The expression of work is that work done is equal to force into distance. That is the expression of work done. Means, so now we write the definition of say work is said to be done when force apply and body and the object, or we can say body and the object move some distance. So that is our definition of work. So now we will, students, discuss the two cases that W is equal to F dot S. If you want to do work done, students, both components must be present in their factor. Suppose, firstly we will discuss that suppose F is equal to 0, then W is equal to F dot S, then W is equal to 0 dot S, it means 0. It means if S is equal to 0, then work done is also 0. Okay? And the second case is that suppose if displacement is 0, in this case also, as we know that the work done is an expression of F dot S. If S is 0, then work done is also 0. It means if F and S, if one of the component is 0, then work done is also 0. Firstly, we will discuss the example of this and this. First example is that in which force is 0 and the work done is also 0. What is the example of that? The force is equal to 0. It means, students, when we go on some hilly area, all we know that when we go on a hilly area and when we go up on a hilly area, or when we go down on a hilly area, then downside we have not required any force. Our car or a vehicle will move towards itself. It means F is equal to 0, but displacement is not equal to 0. But in this case, when force is equal to 0, then work done is also 0. It means when we go on a hilly area, or when you down on a hilly, when you come down on a hilly area, then there is no work done. Okay. And the second case is that displacement is 0. Suppose, students, this is a wall. Okay. I will push this wall. I am continuously applying the force, but displacement is 0. So that is the example of second example, that I am applying the force but displacement is 0. It means when displacement is 0, work is also done. In the previous example, we also discussed that when one of the component is 0, then work is also 0. That is the work done. So student, that is the expression of work done. And also we discuss the two cases, when F is equal to 0 or S is equal to 0. So students, we can understand the concept of work from very different examples of a daily routine activity. Okay, for other examples you can also study, you can also observe your daily activity, you can also observe your daily your all surrounding activity, and from those all surrounding activity we also we can easily understand the concept of work. Okay students, now we can calculate the units of work done. As we know, W is equal to F dot S, means and the force units, and the unit of the force is Newton, as we all know that, and the distance unit is meter. So work done unit is Newton meter, and the Newton meter is also is equal to joule. Okay student, the Newton symbol is N and the meter symbol is M. Similarly, joule symbol is G. So now here we can write that the units of work done. The units of work done is that Newton meter, or we can say that is the joule. So here we write units of work done. Units of work done is joule. Here we write the definition of 1 joule also. The 1 joule is that the definition of 1 joule is that when 1 Newton of force apply, the object moved 1 meter distance along the line of action of force. Along the line of action of force, that is the joule. So now definition of joule is that when you apply the force of 1 Newton and the object move 1 meter along the line of action of force, that is the definition of 1 joule. Similarly, with students, we can also calculate its dimension formula also, but here we cannot study its dimension formula. And now next we will able to understand the other concept also. Now we will discuss one of the numerical here. Suppose students, you have an object. Suppose you have an object and you apply the force of 7 Newton, and this object will move a distance this, and this distance is 5 meter, and you will solve the problem. I can say that calculate its work done. So as we know that work done is equal to force into displacement. Okay, so now force is 7 Newton we given in the example, and the distance is 5 meter. So calculate its work done. W is equal to 7 Newton into 5 meter, that is a 35 Newton meter, or we can say that is a 35 joule. So here we calculate the work done. Students, now I will give you another example. You all will able to solve. Now suppose another example is that if I apply the force of 9 Newton and the object will move 10 meter distance. Now calculates its work done. Students, you can do it by yourself only. Okay, and then we can discuss on the next lecture that what is this, what's the answer of this question. Okay students, now the another concept is that work done is positive or work done is also negative. Now what is that? Okay students, work has to sometimes we can say that work is positive or work is negative. Now we understand the concept of that. Now we understand the concept of that when work is positive or when work is negative. Firstly I will explain that why I can say that that work is positive or can negative. Suppose if you have an answer of plus 10 joule, I can write this number randomly. You can write here any number like 20, 50 or 100. Suppose you have an answer that that work done is equal to plus 100 joule. It means here work is positive. And when you write W is equal to minus of 10 joule, it means here work is negative. Now we want to understand the concept of that, how you can able to recognize that when you can write positive or when you write negative sign. Okay, so concept is that behind the work is positive or negative, that when you apply the force and the displacement is occur in the direction of the force, means we can say that when force and displacement both are occur in the same direction, then work done is positive. if force and displacement are in opposite direction, then work is negative. Simple, students. What I say, when F and S both are in same direction, then work is positive. And the second example, that when F and S both are in opposite direction, then work is negative. It means when F and S makes an angle 0 degree, then work is positive, and when F and S makes an angle 180 degree, then work is negative. So it makes an angle is 0 degree and work is negative. It makes an angle is 180 degree. So this firstly we will discuss the example of this and then on this. Okay, first example is that when work is positive. Okay, example is that suppose I have this object. Okay, I apply the force and the object also move in the direction. Okay, displacement is on this direction, the direction of north, south, east and west. Okay, force apply in the east direction and the displacement is also occur in the east direction, means force and the displacement both are in same direction. It means we can say that the work is positive. So here when we calculate our answer, then simply we write the work is positive. Okay, student. Now we will discuss the example of it when F and S both in a positive direction. Simply understand the concept of this. For students, if you are going on a road and when you apply the force, when you apply the force in your cars, or we can say that when you apply the brake, your car or your vehicle stop. Means your car wants to go in a forward direction, but when you apply and you are applying the force in the opposite direction, that you want to stop the car, it means that force and displacement are in opposite direction to each other. That is the example of work done is negative. I can explain you some more example. Is that suppose in my hand this is a marker. As we know that gravitational force is always occur in the downward direction, but when we want to go in the upward direction, always we apply the force against the gravitational force. And when we apply the force against the gravitational force, in this also case work is negative. Means displacement is occur on upward direction, but those force which we apply, that is the against of the gravitational force, in this case also work is negative. Simply students, you can understand the concept of work is that when F and S both are in opposite direction, when displacement is in upward direction, force in the downward direction. If displacement in south direction, then this will go in the north direction. Both are opposite to each other or 180 degree angle to each other. So that is the example of here we discuss two example, that when we apply the force against gravitational force, then work is negative. Okay, and the second example is that when work is negative, when we apply the brake on a car, when we apply the brake apply the brake on car to stop the car, then force is applying in opposite direction to distance. In this case also work done is negative. Okay students, here's the two examples that when work is positive or when work is negative. So students, here we can and in the last now students, here here the concept of work is completed, and now we discuss some questions that here we discuss some of the questions that in your textbook the question are given that when do we say that. First question is that when do we say the work is done? We can say the work is done when the object displays its position, then we can say that work is done. Okay student, first question is that. And second question is that write the expression of work done. The expression of work done is that W is equal to F dot S. Okay, that's the answer of second question. And the third question is that define 1 joule of work. 1 joule of work, 1 joule is that when 1 Newton of force is applied and the body move 1 meter distance along the action of force. Okay, and the fourth is numerical is given. In this numerical, it's a simple example I will discuss with you students. What's the examples that in this question, that's a simple question student. Force is given, that is a 140 Newton, and the distance in question is given, that is a 15 meter, and you calculate the work done. Students, I can you also do yourself by this question. Simply write down the expression W is equal to F dot S and multiply the both the quantities, and you have obtained your answer. So here I discussed the whole concept of work, and your questions is also that given in your textbook, and other later on we will discuss the concept of energy. From the energy we can also discuss this concept, our daily routine activity. So I hope students you enjoy this session. Okay, next we will meet on the next day on the topic of energy. Thank you.